Hello, everyone, and welcome back to Learning with Jelly. Today is day 14 of our 30-day SQL challenge. Today, we are going to introduce how to join tables in SQL because at times you may have data scattered across more than one table, and you're going to need to join those tables together in order to do your analysis. So, let's look at the agenda for today. We're going to talk about inner joins and left joins. I'm going to talk about right joins very briefly, and then we're going to get into practice with SQLite. We are going to have a second video about joins on day 15. So this is just an introduction. So, if you are new to the 30-day SQL challenge, welcome. We're so happy to have you. The goal is to work for 30 days, preferably straight and consistently. I know that is difficult, but you got this. So that you can learn beginner to intermediate SQL skills to apply to SQL projects and hopefully land an entry level role in data. So, there are two QR codes on the screen. One is a topic list, which is going to have links to the video and supplemental resources. I'm going to put that link in the description below. And the second is a Facebook support group where we have a SQL 30-day chat where you can ask questions about the video, get feedback after you have Googled and tried to troubleshoot on your own. You can ask us to help you troubleshoot your code. You can find a study buddy and more. So please, please, please refer to these links in the description below. So let's get started. What are joins in a nutshell? Joins are combining rows from two or more tables using a related column. So most of the time, these tables will have some type of column that is identical in both tables. There are multiple types of joins, even more than what you see here, such as cross joins and self joins. We're not going to talk about those in this video. But the main ones that I'm going to discuss today is the inner join and the left join. I am going to discuss the right join, but I'm going to tell you how all right joins can be written as left joins. So you really only need to know these top two to get started with joins. So inner joins. So inner joins, as you can see, has the green highlighted in the intersection of the tables. That means it's only going to return matching rows. So this is table one, where I have the ID, state, and total column. Table two has ID and city. Notice that both of these tables share a common column like ID, so we can join these two tables on ID, and it's only going to return matching rows. So the two IDs that are the same in both of these tables are going to be IDs 1 and 3. So our output is going to have all of the columns. So state, total, city, as well as ID in this case. And we see that we have joined the information together. So this is what an inner join is. You only return matching records across both tables. So you shouldn't get any nulls or missing values in your output unless the data tables have nulls in them to begin with. So if I had null values in table 1, that still should show up in my output. But I should not get nulls purely from joining the data. And you'll see what I'm talking about. So this is how the syntax looks. So the basic syntax for inner join to get out those matching rows is selecting the columns that you want to return from the first table, table 1, and then now we have another clause here, inner join table 2. So the second table that you want to join to on table 1 dot common column equals table 2 dot column. So you want to join both tables on a column that they have in common. So if we were to look at a quick example here, I'm selecting all of the rows that I want from track, inner join album. So track and album are my two tables on track.albumID equals album.albumID. And notice here that I have a T right after track and an AL right after album. Those are table aliases. So just like you can alias a column, like we talked about in a previous video, you can add an alias on a table so that you don't have to keep retyping the name, track, or album over and over and over again. So the T.album ID says that the album ID from the tracks table, and the album ID with the .al in front of it comes from the albums table. You can also see in the select statement how I have a T in front of name. So that means both of these tables have the variable name, but I only want to return the name column from the tracks table. So if there is a variable that both tables have in column common, you can specify which variable you want to keep in your output. Do you want to keep the variable from table 1, in this case track, or do you want to keep the name variable from table 2, which in that case will be from the album table? And the name column in the track table is the track name, whereas the name column in the album table would be the album name. And then we're getting al.title as album title. Okay, so the keyword here is inner join, and then the next keyword is this on. So left join. Left joins are going to return everything from the left table or table 1, regardless if it has a match or not. So I want to return all of my customers, regardless if they have made a purchase in the last 6 months or not. So it's going to return everything from the first table or table 1. So in this case, I'm going to return 1, 2, and 3. I know that 1 and 3 are the only rows that have matches. So when I return table 2, since it didn't have a matching city, I'm going to get a null here. So when I do things like left joins or right joins, I can get nulls in my output if a row does not have a corresponding match, because I want to return the data from the left-hand table regardless if it has a match or not. So the syntax there, similar syntax here. Instead of now from saying inner join, we're saying left join. So table 1 is album. So you're going to return all records from the album table, regardless if it has a match or not. And you are going to left join on artists. And their common column is artist ID. So al.artist ID is equal to ar.artist ID. Keep in mind that the columns do not need to be named the same. So say for instance, in the album table, artist ID was just artist number, and in the artist table, it was artist ID. As long as I know that these two columns are the same, they do not have to have the same name. Okay, so this is a left join where I will return everything from the album table, regardless if they have a matching artist or not, because maybe we don't know if every album would have an artist. Right joins is you're going to return everything from the right table, regardless if it has a match or not. So in this case, I'm going to return IDs 1, 4, and 3, regardless if it has a match on table 1 or not. So 4, you see that I have null for state in total because I have no ID of 4 in table 1. So this can also give you null values in the output. So if I wanted albums to be the table on the right, I would just switch artist and album here in this syntax, because all right joins can be written as left joins. So now artist would be the left table and album would be the right table. So it's how you order it. And this is exactly what I say here. All right joins can be written as left joins by switching the order of the tables. SQLite doesn't support right join syntax. So there is no right join in SQLite because they know that all right joins can be written as left joins. Just switch the name of the table. So in this case, employee is on the left. If I wanted employee to be on the right, I would just put it after the left join here and swap. So in this case, this is an example of how I'm joining on two different columns. In the employees table, it's called the employee ID. In the invoice table, it is called the support rep ID. But these two columns are the same, and I would know that by looking at the entity relationship diagram, or ERD. Notice that we have some different syntax here where I am concatenating or joining two words together. So this says take the first name of my employee, add a space, and then take the last name of my employee, and then create a new column called employee name. So this is some new syntax that we haven't seen, but we will see it in future videos. Okay, so the ERD, and this is going to be linked in the description below where it says Chinook database. You can see what columns are related to each other. So in this case here, I have employee ID in the employees table. See how it matches up to the support rep ID in the customers table. I see that the playlist ID in the playlist table matches up to the playlist ID in the playlist track table. So definitely have the ERD open so you can see how you can join data to get the information that you need. Okay, so let's actually practice this. So let's go into SQLite Studio, and I have some questions here. So the first question is, I want you to give me a list, and let me go ahead and just collapse these columns. Don't want to have too many of my tables open. It makes it hard to look at. So I'm in the Chinook database, as I see right here. Give a list of customers who have matching invoices only. Return customer ID, invoice ID, and invoice date. So I only want a list of customers who have an invoice. I don't want a list of customers regardless of if they have an invoice or not. So I only want matching records here. So I can look at my customers table. I see I have customer ID. I can look at my invoice table, and I also see that I have customer ID. So I'm able to join the customers table with the invoices table to get a list of customers who have matching invoices. But I'm going to explore the data a little bit more. So do you remember how we actually counted up the number of rows in each table? I am going to do that here. So I'm going to select count from customers, and I just want to see how many rows I have. I have 59 rows. So I have 59 customers here. So in that case, when I join these two tables together, I shouldn't have more than 59. I should have 59 or less because it should only give me customers that have a matching record. Let's look at this from invoices. So let me look at the invoices table and see how many rows I have there. I have 412 invoices. Interesting. So that means that I can have a customer that has possibly made more than one invoice or more than one purchase. So those are some good things for me to know on the back end. But let's go ahead and do our join. So I want to select customer ID, as well as invoice ID, as well as invoice date. And I want to select where I'm doing from the customers table, join on the invoices table, the on clause where I have customers dot customer ID equal to invoices dot customer ID. Great. So this is what I have here. Now, how could we have shortened this? And what customer ID do I actually want to return? Well, I only want to return the customer ID from the customers table. So I'm going to put a C dot here. And next to customers, I'm going to alias it as C. And next to invoices, I. So now I'm just going to put a C here and an I here. And now I'm going to run this. And I see that I get my customer ID. And this is exactly what we thought because we had a lot of rows in the invoice table compared to the customer table. So this actually shows me that I have one customer making multiple invoices on different dates. So I expect to have duplicate customers in my result. Okay. This is a one to many match where I've matched one customer ID from my first table to many records in my second table. So we call that one to many. So this is actually what I get out. This is great. So now let's go ahead and do our second question. So now I want to return all tracks, regardless if they are a part of an album or not. So sometimes people release tracks and they just have a one hit wonder. They didn't actually put out an album. So I want to release all of the musical tracks that I have, regardless if they are part of an album. But I do want to return album name as well as track name to get a list of those tracks. So I'm going to go ahead and look at the data. So I have tracks here, I have the albums table here. I see that both of these share album ID with one another, so I could join on that perhaps. I see that there is the name of the actual track inside of my tracks table. And if I want to get, do I have anything about my album names? Nope. Artist ID and name. Oh, we have title. So the actual album title. Awesome, awesome, awesome. So let's go here. And I'm going to look at my tracks again. So I'm going to select everything. Let's do a count from tracks because this will tell me how many rows I have in that. And I have 3,503 tracks. Awesome. And so I should return all of these tracks regardless if they are part of an album or not. So let's actually do the join here. So I want to select, let's say, name for the track. I also want to select title, which is the title of the album. And I want to select, that's it. Let's do that. Name and title. So from tracks, I'm doing a left join because I want to return everything from my left table. Left join albums. And let's go ahead and add an alias to this. Tracks is going to be T, albums is going to be AL. And I'm going to do on what they have in common. So it's T dot album ID equals A dot album ID. And I see that the name column only exists in the tracks table, so I don't need to alias it. I can if I want to. And I see that the title column also only exists in the albums table, so I don't have to alias it, but I can if I would like to. And let's see here. Oh, I put AL. I need to put AL there. That's what the error was saying. We don't know A, we only know AL. And this is what I get. So this is the name of the track and the album that it corresponds to. And at first glance, I don't see any missing album names. So that's great. Let me go ahead. And that's all. Great. So awesome, awesome. That was our join for that. Okay. So now for 3, we want to return a list of all album titles and the names of the artists. So I have an albums and an artist table. It looks like both of these have artist ID. So let's go ahead and do a select. And I'm going to select title of the album. And I also want to select name from, and I want to return all album titles regardless if they have an artist associated with or not. So I'm going to put albums on the left. So I want to do the albums. I'm going to do AL, left join, artists, and I'm going to put AR. on al dot album ID, no, artist ID, because that's what they have in common. Artist ID equal to AR dot artist ID. Great. So now I'm going to run this. My query finished. Where's my actual results? Here we go. So there goes my results. So in this case, this is the title of the album, and this is the name of the artist who actually made that album. Okay. Now, if I wanted to return all artists, regardless if they've made an album or not, I would put artists as the first table after from and still do a left join. Okay. So let's hop back into here. This was a mouthful. So thank you all. I know when I first started learning joins, it took practice and me going through videos more than one time. So feel free to go back through this video, go back through this practice, look at the ERD diagram here to see what other tables you can join and just practice joining data together. Thank you all. Please like, comment, and subscribe. I'm going to have my Etsy link below as well as buy me a coffee, and I will see you in the next video. Bye bye.